Let's talk about the problem traffic times from activity 3, making decisions, and this is from part 2. So it says traffic times from the airport to the city are worse during the weekend than during weekdays. Also, they're better during the night than during the day. The following table indicates average times in minutes, but one of the data was not included. As you can see, night in weekend, right? Weekend night is not included. You will be riding a bus on Sunday night. That means night weekend, right? Your job is to predict the weekend night entry based on the other 3. There are several possible answers, but justify whichever number you propose. So the first thing to understand is we're not looking for a single right answer. There's several approaches to this problem, but of course not all answers are valid, right? I mean, we have to justify what we do. So first what we can see is to check that actually the problem is telling the truth. And it is, right? Because weekend gets more expensive, $40 than weekday. Not expensive, but minutes, right? 40 minutes, it's more than 24 minutes. And on weekdays during the night, you just need 18 minutes, whereas during the day you need 24 minutes. So one way to try to see this problem, so option 1, is to look at something that we would call absolute change. So not percentual change, but just absolute change. And what we can say is look from 24 to 18, I am saving 6 minutes, right? So that's kind of we can put it here, a -6. And so we would expect, if the same logic applies, and so that's when we are assuming that logic applies. We don't know, but it's a good assumption. It's a good mathematical assumption. This -6 here, if we go to this -6 here and apply it again, well, we'll get 34. And what's cool about this is that actually from 24 to 40, if you go during the day and compare weekday to weekend, that increases a lot, right? If you go from 24 to 40, so that's 16 more minutes, so plus 16. And it is consistent here, so that's nice. It's also a plus 16. So 34 is one good answer. If you're assuming that this is just absolute change, which may or may not be right, it just depends on the real world, which city you're considering. But you don't want to, go into those details. That'd be just, more complicated optimization problems or modeling situation. But this is a good answer, 34. Let's explore another one. So that's one way. The kid might predict this to be 34. And it makes sense, yeah. Option 2, let's do percentual change instead of absolute change. So percent change or fraction change, right? It's really the same. And what we can do is the following. We can go, for example, from 24 to 18. And so what's a fraction that turns 24 to 18? And this is a nice problem. If I divide 24 into 4, I get 6. And if I multiply by 3, I get 18, so 3/4. And so if we apply the same fraction, and so here we would be assuming that the same percentual decrease applies in weekdays than in weekend. In both weekdays and weekends, going from day to night is the same percentual decrease or relative decrease. So 3/4 and 3/4 of 40, well, that's 30. Divide by 4, multiply by 3. So that's another option, postulating that it's not 34 but 30. How about option 3? If we do it in the rows, this percentual change, instead of doing it in the columns. So look, 24 to 40, what would be a fraction that allows me to go from 24 to 40. And so, well, we could do the following: divide 24 into something that fits into 40, right? And so we could, for example, do thirds. So if we do 24 divided by 3, that's 8. And 8 times 5, it's 40. So 5 thirds, which is, because we know 1/3 is around 33%. So this is a 66% increase. It's a big increase. And if we do the following, the same procedure, 5 thirds to 18, we would get 18 divided by 3, that's 6, and 6 times 5 is 30. So magically, we get the same result as before. So that's option 3, is the same as option 2, really, as we saw. Option 4, which would be nice, is to take average. It's like saying, hey, we don't know if it's going to be an absolute change or a relative change. These are two options. Let's take the average and, kind of cut in the middle as a prediction. So this is really an exploration of what kids are going to do after, in the high school years, which is actually consider models that describe reality, in a more detailed way. This was in very, very detailed.